Dear students, welcome to the problem solving session on the transformation of W equal to 1 by Z part 4. In the first three videos, we solved four different problems where x should be less than 1 or x greater than 1, y less than 1 by 2, y greater than 0, all these conditions. In today's session, we are going to see a special problem under the transformation W is equal to 1 by Z. The general problem y greater than c when c is negative. Similarly, x greater than c when c is positive. So as usual, step 1, fill the known informations w bar, z bar and the given relation w is equal to 1 by z. Step 2, the given data are in terms of x and y expressed in terms of u comma v. For this, we are taking w is equal to 1 by z, simplifying that, rewriting as z equal to 1 by w, multiplying and dividing by the conjugate w bar and substituting the value of z, w and w bar, we get x plus iy is equal to u minus iv divided by u plus iv into u minus iv. We know that u plus iv into u minus iv is u square plus v square. In the numerator, we have u minus iv. Now splitting this, I can easily find the real and imaginary part. Up to step 2 is common for all the problem under the transformation w equal to 1 by z. Now we found x and y in terms of u and v. Next we have to deal with the question. At first we take x greater than c. X is u by u square plus v square, that is greater than c. So now simplifying this, we get u by c greater than u square plus v square, rewriting this as u square plus v square less than u by c. Finally, I can write this as u square plus v square minus u by c less than 0. Very important, here c is positive, so it is no way affect the problem. The coefficient of u square and v square are same and it is 1, so it is a circle, but we have less than 0, so it represents the interior of the circle. Done. Now we are going for the second data, y greater than c. This is going to be the heart of this problem. Why I took this problem, this is little different. Y greater than c provided c less than 0, that is c is negative. We know the value of y minus v divided by u square plus v square greater than c. See here, u square is positive, v square is positive. When you add this both, this is completely positive. So I can take this to the other side. So this can be rewritten as minus v greater than c into u square plus v square. But we cannot bring this c just like as the previous data because here c is positive, so I can multiply or divide in the inequality, it will not affect the inequality. But in the second case, my c is negative, c less than 0. This will affect the problem. Why? For example, you take 4 greater than 2. If you divide by 2, you will get 2 greater than 1. The inequality is not affected. But for the same 4 greater than 2, if you are dividing by minus 2, you get minus 2 in the left hand side, minus 1 in the right hand side. We know that minus 1 is greater than minus 2. So if you divide by a negative term, the inequality changes. So the same thing I am doing here. If I divide by c and c is negative, that is less than 0, my inequality will change. So we get minus v by c less than u square plus v square. All our previous problems, we have constants like 1, 2, 1 by 2, all are positive. So we don't bother about the inequalities. But in this case, my c is negative. So we should deal this with very carefully. Rewriting this, we get u square plus v square greater than minus v by c. Simplifying further, we get u square plus v square plus v by c greater than 0. The coefficient of u square and v square are same and it is equal to 1. So it represents the circle, but we see we have greater than 0. So greater than 0 means it is the exterior of the circle. So this is very important part. If you do a small error, you lose everything. Next we have to find the center and the radius r for both the circles. The general equation of circle is known to us with center minus g comma minus f, radius square root of g square plus f square minus c. For the first circle, just take the equality u square plus v square minus u by c equal to 0. Now equating the coefficients of u from the general equation, we have 2g. In our problem, it is minus 1 by c. Therefore, my g equal to minus 1 divided by 2c. Next, the coefficient of v in the general equation is 2f. Our problem does not consist of v, so it is going to be 0. So we found f equal to 0. Next, we have to find the center minus g comma minus f. My g is minus 1 by 2c. So minus g is 1 by 2c comma 0. Next, the radius g square. So minus 1 by 2c whole square. F is 0. Constant is 0. So we get square root of 1 by 4c square. Taking square root, we get 1 by 2c. Since r is positive, we have to take only the positive value. This is my radius. Next, we have to go for the second circle. Here we have to deal very carefully. I am taking the equality. Same thing, comparing the coefficients of u in the general equation, we have 2g. Here no u term, so it is 0. So I get g equal to 0. Next, comparing the coefficients of v, we have 2f in the general equation, 1 by c here. So f is equal to 1 by 2c. Therefore, my center is minus g comma minus f. Here g is 0, f is 1 by 2c. So minus f is minus 1 by 2c. And the radius is square root of 0 square 1 by 2c, that is my f square minus 0. By simplifying this, we get radius is 1 by 2c. Since c is less than 0, I cannot write my radius as 1 by 2c. It will become negative. So I write my radius as modulus of 1 by 2c. In some book they write like 1 by 2 into mod c. Both are correct. Next we have to draw the diagrams. In the z plane, we have given x greater than c, c greater than 0. Now, any line x equal to constant is parallel to y axis since c is positive. Now, I want to find x greater than c. It is easy to see the right hand side after the line x equal to c is x greater than c. Next, we are going to see how this is mapped into w plane under the transformation w equal to 1 by z. The center is 1 by 2c, comma 0 and the radius is 1 by 2c. Just draw the circle and go to the step 2. This is interior of a circle. So if I take a circle, I should not take the border. I have to take the interior values of the circle. So we have to shade the interior part of the circle. Therefore, x greater than c maps into interior of the circle. Next, we are going to draw the image for y greater than c. Very important, c less than 0. First draw the axis. Y equal to c means a line parallel to x-axis. But c is negative, so the line will be below the x-axis somewhere like this. This is y equal to c when c less than 0. Next, y greater than c means 4 is greater than 2, but minus 4 is less than minus 2. So y greater than c means, suppose you are taking this as y equal to minus 4, then y equal to minus 2 is bigger than minus 4. Y equal to minus 1 is bigger than minus 2. It goes like this. Therefore, y greater than c lies above the line y equal to c. Why? Because my constant is negative. Next, when you come for the w plane, the center is 0, minus 1 by 2c and radius is modulus of 1 by 2c. Since c is less than 0, whatever the value you take, always the y data will be positive. So we may get 0, 1, 0, 1 by 2, 0, 3, 0, 4, any value above the u-axis. So now I mark this as 0, minus 1 by 2c. Let us draw a circle with radius modulus of 1 by 2c. Now again see the second data. It represents the exterior of the circle. So whenever I draw a circle, I have to shade the exterior part of the circle. So I have to shade like this. This is the transformation happened from Z plane to W plane under W equal to 1 by Z. So Y greater than C when C less than 0 is turned into a exterior circle in W plane. Hope you understand, students.
Thanks for watching. Hope you found this video helpful. Subscribe to our channel and share it to your friends. See you in the next video. Bye bye.